Hi everybody, welcome back to Miss Angler's biology class. I am Miss Angler, and in today's video we are going to be looking at a nervous system exam question. This particular one is a medium level in difficulty. I'm going to walk you through how to correctly answer this question. So if you want to pause the video now so you can attempt the questions first, please do so. Now, if you like this video, don't forget to give it a thumbs up and make sure you are subscribed with your notifications turned on because I post new content every Tuesday and Thursday. If you are in matric and you're thinking about improving your mark, getting a distinction in your finals, you should consider joining my membership. In the membership, you get access to my cheat sheet summary notes as well as live lessons and exclusive members only videos where you can request topics that you want me to cover just for you. So let's dive into the question. Now, this particular question I did say was a medium level, and it just requires a little bit of interpretation, and that's why I think it's a bit of a more medium in terms of challenge. But let's break down the question. So it says the graph below shows the speed of an impulse traveling through neurons of different diameters, diameters meaning widths. Now, the diameter of the neuron was measured in micrometers or in our little micrometer unit of measurement, and the speed of the impulse of a nerve was measured in meters per second. And so we have a graph there showing us what's happening. And I think it's important to take a quick moment here to just break down what we're looking at, because often we rush too quickly over this and we don't take enough time to actually interpret the graph. So at the bottom here, we have the diameter of the neuron, and that's the width of the neuron. And then we have the speed of the impulse. Now, as you can see, the graph is increasing over time, and that leads me to believe that as the diameter of the neuron gets larger, so we're going this way, as it gets larger, the speed increases. So that's their proportional relationship. So as one gets wider, the speed of the impulse gets faster, and that's going to be key to understanding this diagram as well as then answering the questions that follow this. So looking into our first question, it says use the graph to calculate the percentage increase in the speed of an impulse between a neuron of 6 micrometers and one with 8 micrometers, and you need to show all your calculations. Now, in order to calculate percentage increase, and the same for percentage decrease, what we need to do is we need to take our two numbers. So let's just take them off of the graph. So we're going to go to 6 micrometers, which is this one over here. So we have 40. And then it says at 8, which is 45. So we're going to take the bigger number and we're going to minus the smaller number from that. That should give us 5. We then take the difference of the two and we're going to divide it by the initial amount, which is 40. And then when we're done doing that, I'm just going to put a bracket around that because we do that first. Then we multiply it by 100, and that will then give us our percentage increase or decrease. But in this case, we're looking for the percentage increase, and we should get 12.5% percentage increase in its speed. So in case you didn't catch that the first time, what you need to do is you need to take your final value minus your initial value, get an answer, in this case it's 5, and then divide it by the initial amount times by 100 to get it into percentage, and that gives you your percentage increase. So let's move into the next question. It says, which other structure in a neuron can increase the speed at which an impulse travels? Now, for this, you need to have quite a good understanding of the structure of a neuron and what the functions of its components are. Now, you can, of course, actually find this in the guidelines because it does speak about the structure of neurons, the significance of neurons, but the specific thing that they are looking for here is what increases the speed at which the impulse travels. Now, we have learned about the structure of the neuron, and we know on the outside of a neuron, we are going to find a fatty layer. So if this is our neuron with its dendrites sticking around off the edge here, then sitting on the outside of our axon are these sections of fat, and those are called the myelin sheath. The myelin sheath is great for conducting impulses much faster. It increases the speed actually, because what happens is the impulse jumps from one to the next, and because there's a little space in between each of them, that increases the speed at which it travels. So I'm going to say myelin sheath for that one. For the next question, it says, what is the relationship between the diameter of the neuron and the reflex action? Now, we just spoke about this when I broke it down for you. And the relationship means, what is the relationship between the two variables? What is the relationship between the diameter of the neuron and the speed at which the impulse travels? And in this case, we already spoke about it. We said that as the diameter of the neuron increases, the speed of the impulse or the speed of the reflex is going to increase. You can, of course, answer this in the opposite. So you could say, as the size of the neuron decreases, the speed of the neuron decreases. So in other words, you can either talk it going upwards, in other words, the relationship is a positive relationship, or you can also, speaking downwards, you can speak how everything is going slower in the opposite or in the negative. I prefer answering in the positive in exams. It's often suggested that you shouldn't answer questions in the negative. In other words, answering the opposite of what the question is asking. Then we move to the next question where it says, name the functional gap found between two adjacent neurons across which an impulse can be transmitted chemically. It's only for 1 mark, so I only need one word. And I think we all know that this is the synapsis. It's the empty space. I think also they may accept here synaptic cleft, because that's another way of describing that space. And then last but not least, it says draw a labeled diagram of a sensory neuron and indicate the direction in which the impulse travels. Now, I'm just going to remove this picture that I started drawing at the bottom here because it is a little bit in my way. And we're going to be able to just see what that would look like. So number one, step one, you need to make sure that you know that a sensory neuron has its cell body off to the side, which is a key thing that people forget. And then likewise, when you are drawing out your terminal branches and your dendrites, you need to make sure that you are making them clearly different. And you'll see what I mean by that now as I draw my dendrites. So you can see I've made them look quite different. And according to the question, you also need to indicate the impulse in which it travels, the direction. And so as we know, impulses always travel from the dendrites through the axon terminals and onto the next neuron. So that's where I'd put my arrow in. And then because it's out of 5 marks and it's important to look at your mark allocation, I always think that a minimum of 3 labels is really important. And there's quite a lot of things you could label here. You could even add in a couple of pieces of myelin going along here too if you wanted to. And so that gives you lots of options in terms of labeling. You could label the dendrites over here. You can label the myelin. You can label the axon, the cell body, the nucleus, the axon terminal. So there's a lot that you can label here, but I would do a minimum of 3 labels. And last but not least, also make sure that you have a heading at the bottom of your picture, because they often also allocate marks for that as well. Now, looking ahead here to our memo, please take note of the memo and how they have answered or provided the marks for these answers. Just to draw your attention to question 3.3.3, you'll notice there's a double tick in either of them, and that's because you have to say everything to get both marks. It's an all or nothing, and so that means that you must have a link in the relationship, which was that particular question. And then here is our diagram question. Just for a moment here, please note the direction of the impulse. And that the direction of the impulse over here will only be correct if your dendrites and your axons are the right way around. In other words, if you swap these two over, then they expect you to have your impulse going the way that I drew it. It doesn't actually matter as long as your axon and your dendrite is whichever side it is, your impulse must move from the dendrite to the axon. So it doesn't matter if you swap it around like I did. One other thing I just want to clarify for everybody also while we look at this diagram and we look at nerves and neurons, I want you to know that when we talk about axons and dendrites, the cell body is the most important thing to tell us which side is which. And so just a reminder, everything before the cell body, which is everything this side, is a dendrite. Everything after the cell body is an axon. And so that means that these two structures actually move in motor neuron neurons as well as in connector neurons or interneurons, because the cell body is not in exactly the same place. But most often people get the motor neuron one incorrect. And the reason for that is normally a motor neuron looks something like this, with its dendrites sitting at the top here, because this is the cell body. And so actually, this is the dendrites, and everything below that is an axon, which is a little bit different to the picture that we've drawn over here, which isn't the case. Now, if you have enjoyed this video, don't forget to give it a thumbs up, and good luck with your exams or your tests if you're preparing for one while you watch this video. And I hope to see you all again soon. Bye.